how to calculate the equivalent resistance for three resistances which are connected in series. The same formula applies to any number of resistances. Here we have 3, it could be 5 also, it could be 10 also, it could be 100,000. Then we have to use the same formula which we have got here. If we want to replace even 100 resistors with only one equivalent resistance, so then we have to use this formula to find out the value of equivalent resistance. Now what if here I hope you people can see it, equivalent resistance for three resistances each having a value of R in series combination. So previously what we have seen that we had three resistors R1, R2 and R3, and all the three resistors they have a different value. Now what if all the three resistances they have the same value? What would the formula be like? So if we have three resistors which have the same value, which is R means what? R will be some value. It could be in question, you will see sometimes they will give us 5 ohms, sometimes they could give us 10 ohms. So R can have any value, actually it is a variable. So equivalent resistance for three resistances, each of the resistance is having a value of resistance R. That means all the resistors they have the same value. Okay, so we know that equivalent resistance is always obtained by adding the value of each resistor. So R plus R, and it will become total equivalent resistance will be is equals to 3R. Fine. Now what if there are n number of resistors? N means it could be 100,000. Okay, so what if there are n resistors, 100,000 resistors, they are connected in straight line in series with each other? Then how to find the value for that? So if we have n resistors connected in series, and each resistor, every resistor has a value of R, that means all the resistors, 100,000 resistors, they have the same value of resistance. So if one is 5 ohm, second one is also 5 ohm, third is also 5 ohm, so on and so forth. Now, so again we know that how could we obtain? By adding the value of each resistor. So you can see here in the previous case what we have seen, if there are three resistances having the same value when connected in series, so then it will become number of resistors times the value of each resistor. So 3 into R. Similarly, if there are n resistors connected here, R, so we have to add all the values, or what we can do, what we have observed from previous equation, we have to simply multiply it to find the equivalent resistance. We have to multiply simply the value of every resistor with the total number of resistors. Fine. So here if R equivalent we have to find out, so simply how many resistors are there? There are n resistances. So n could be any value, 100, 1000, 2000. So we have to simply multiply this R with n and we will find out the value. Very simple and very easy to calculate, but everyone has to remember that whenever the resistances are in series, the equivalent resistance, if we want to remove 100,000 resistors and we want to use only one resistance, its value is obtained like this: number of resistors, total number of resistors connected in series multiplied with the value of each resistance. Fine. Then there is a question, we'll see. Again, three resistances, there are total three resistances, and every resistance has a value of 3 ohms. Each of 3 ohms means every, very important here is each. That means every resistor has a value of 3 ohms and they are connected in series. Find the equivalent resistance for the combination. Okay, pretty simple and very easy. So what do we know? First of all, given we know that resistance of each one is 8 ohm. Very sorry, this should be ohm, but it is changing here. So the value for each resistor is 3 ohms, and how many resistors here? There are 3. Now there is a mistake, so I hope you people will correct it while solving the problems. Fine. Then what do we have to find? We have to find the equivalent resistance, because there are 3 resistors and every one has one value. So what we can do is multiply value of each resistor to the total number of resistors. R equivalent is equals to total number of resistors into value of each resistance. So this will be R equivalent is equals to how many resistors are there? As you can see, 3. So substitute. Very importantly, always everyone has to write the formula, no matter how simple that formula is. Everyone is supposed to write the formula because these formulae contain marks. Writing formula has marks on them. Okay, step 1, get the formula. Step 2, do the substitution. And step 3 is to get the answer. So here, a formula, total number of resistances multiplied by value of each resistor. 3 into 3 will give us 9 ohms. So equivalent resistance is 9 ohm. That means if we replace the 3 resistors with only one resistance, then it should have a value of 9 ohm to produce no change or have the same effect. Fine. Then again, second question, 100 resistances when arranged in series combination. So we have total 100 resistors. Now when these 100 resistors, they are connected in straight line or in series, the equivalent resistance was 5000 ohms. That means if we want to remove 100 resistances and to have the same effect without any change, no change in the circuit, then we have to use a resistance which has a value of 5000 ohms. What is the resistance of each resistor? So hundreds resistances are connected. We have to find out because all the resistances will have, it is not mentioned in the question that resistances had a different value. That means every resistance had same value. So there are 100 resistances connected in series, and if we remove these 100 resistances, we have to use a resistor of 5000 ohms. Then we have to find out what value of resistance was connected in the circuit again. So first of all, given the number of resistors, as you can see, it is 100, and equivalent resistance is also given to us. Then what we are supposed to find? The value of single resistor. What was the value or resistance of one resistors? Solution for series combination, what do we know? We know that if all the resistors have the same value, then equivalent resistance is obtained somewhat like this. R equivalent is equals to N times of R, total number of resistances. But what we have to find? We have to find only R and not R equivalent, because it is already given in the question. Fine. So what we will do? We will rearrange the formula and we will end up like this. R is equals to R equivalent divided by N. So this is our first step, getting the right formula. Second step is do the substitution. So simple, R equivalent is 5000, we know. So we'll put it here, and number of resistors are 100. So we'll put it here like this. And because if we cancel two zeros from top and bottom, so then we will end up getting 50 ohm. So step 1, getting the right formula. Step 2, doing the substitution. And step 3, getting the right answer. I hope all of you understood. In case of any problem, you can contact me anytime or Ashok. Thank you very much all of you. Have a good day.